Hi everyone, welcome back to this playlist about the mathematics behind AI. In the last video we have seen the notion of continuous functions, so we know what functions are, and if we restrict ourselves to functions from R to R, say functions f from R to R, which maps x onto f of x, then we now know what it means for f to be continuous. You can say intuitively, if you would draw the graph of the function f, you can do this in one go without having to lift your pen from the paper. But we actually need a stronger property in order to make some machine learning models, for example, and this is the property of being differentiable. And you might have heard of the word derivatives, and this is everything to do with this. It's also in your higher years of education, you're going to have a course about calculus. That's everything that has to do with differentiable functions. Because let's take a look at the function from R to R, and I drew the graph here. And what I can see is that first the function is like ascending, and then a bit slower ascent, but still ascent, then very steep up. Then it flattens down a bit, a steep descent, a less steep descent, and then it starts to going up again. And we are actually interested at every point of our domain, which is in this case the real numbers. We're interested in, well, how steep is the descent or ascent. And another way to look at this is in every point of my graph, I can draw the tangent line. Draw a tangent line here, or I can draw it here, or I can draw it here. And answering this question actually comes to the fact of saying what is the slope of the tangent line to the graph at a certain point. And for functions for which you can calculate in every point of the domain that slope of the tangent line, if that works, then we can look at the first derivative of the function f, which goes again from R to R and which maps x to f prime of x. And then if that's the case, we say that f is a differentiable function. Well, I will give you the definition of how to calculate this f of f prime of x. Well, this is again using a limit where h is going to 0 of a certain quotient f of x plus h minus f of x divided by h. And of course you can derive that if this limit exists, that indeed this will be the slope of the tangent line at the graph of that function. Now, typically, where can we use this? Typical application of derivatives, first derivative function, is if you have a certain function and it goes like this, then you're actually interested in what we call maybe global or local minima or maxima. In other words, where is the function locally the highest and where is it the lowest? And you can see that it's here, 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 and here. And the way you can calculate those values of x, these guys, and these guys, is by calculating for which x that the first derivative actually becomes 0. In the next video, we're going to take a look at what we call partial derivatives. Ciao.